Good morning students. Up to now we are studying the working of electric motor. Okay. So working of electric motor is based on one concept. That concept tells us that when we place an electric conductor in magnetic field. Okay. If we place electric conductor in a magnetic field and if we pass electricity through that electric conductor, at that time force will be act on that conductor. Okay, due to that force motion of a conductor is a takes place. Okay, that part we have studied in the last topic, and working of electric motor is based on this principle. So there are, we place one rectangular coil in between two magnets. Okay, so current direction of AB and CD are opposite to each other. Okay, so then as we pass electric current, we place two magnet around that coil. Okay, so due to that what happen, magnetic field is present in between that space, and we place our rectangular coil in that space. Okay, so as we start electric current through that coil, at that time force will act on that coil, both AB and CD wire. Okay, in in case of a AB and CD, we see direction of forces are opposite. Because of what happened, the current direction get changes, and we can find out the direction of force act on a conductor by using the Fleming's left hand rule. Okay, so simply in Fleming's left hand rule, that rule tells us that force act on a conductor in the direction of thumb. We have to place our these three fingers such a way that index finger, middle finger and thumb are mutually perpendicular to each other. Okay, so such a way that by using that law we can find out the direction of force which is act on an electric conductor when we place it in a magnetic field. Okay, and current pass through it. Now today we have to see a new topic, that is the electromagnetic induction. Okay, so first of all, directly go towards the electromagnetic induction. First we see why this topic we have to study and what is the importance of this topic, electromagnetic induction. Okay, so the study of this electromagnetic induction carried out by Michael Faraday. Okay, Michael Faraday is actually a very genius student. Their work is very valuable in the physics. Okay, in case of electricity and magnetism. Okay, so in that study this tells us that we can produce electricity with the help of magnetism. Okay, how, that part we have to study. First of all, we have to think about nowadays electricity is important for us. Okay, because all the home electrical appliances generally we are seeing there we use electric motors. Okay, and we know that electric motors are generally run on electricity. Now if very small battery if we consider, okay, so if we consider very small battery, then we have to use their small dry cells. Okay, that energy of a dry cells are sufficient to run that very small home appliances such as TV remote. Okay, or battery. There are, we use dry cells, and by using that we can produce energy in it. Okay, but now if we have to consider our home, okay, if you want total energy to run all the appliances which is present in our home, such a case how much big cells we are need. Okay, now if we extend the limit, suppose we are consider our town. Okay, if you want to run all the electrical appliances on battery in our town, at that time how much big batteries actually we are required. Okay, so as we think about all over the country also, okay, there are also, if you want to run all the appliances by using battery, then it is possible actually? No. Okay, so it is not convenient, it is much more expensive. So the first of all thing is come in our mind, how the production of electricity is takes place. Okay, so first of all, what is the electricity we are using in our home for our many commercial uses, for our any other many uses, that all electricity generate by using this concept electromagnetic induction. Okay, so the electricity which stored in a battery or cell, which are very small scale, okay, but our day-to-day life use and all the working, if you see industries, for there are large electricity is required, large amount of electricity is required, and that electricity is generated by using this concept electromagnetic induction. Okay, so in electromagnetic conduction induction, generally what happen that we have to see now. Okay, so we see that what if we place two magnets, okay, that we studied in electric motor concept. Suppose these are the two magnets and we place here a rectangular coil such as that, and we connect this rectangular coil to the electric battery. Okay, so as electric current pass through, okay, this coil, at that time what happen, the force will act on this coil. Okay, due to that coil is moves. So here one thing is stationary, that are these two magnets. Okay, this magnetic field is present as like that, north to south direction. Okay, so such a way that around these two magnets magnetic field is what present. So in this magnetic field we place this rectangular coil, and as we pass current through it, force act on that coil, due to that coil moves. Okay, and continuously it remains in motion due to the what happen, application of force on a conductor when we placed it in magnetic field. Okay, so we know here two magnets, we are one magnet we are considering a horseshoe magnet. This is the north pole and this is the south pole of that magnet. In between this magnetic field is present. Okay, so that concept we are studying, force act on electric conductor when it placed in magnetic field. Okay, now if we consider this is a one coil. Okay, suppose this is a one coil and we are connect one battery to it. Okay, so as we turn on electric supply, okay, if we turn on the connection of battery, at that time current will pass through this coil. Okay, this circular coil, and we know as current is passed through any electric conductor, at that time one field is generated around that conductor. So again magnetic field is generated around this electric conductor when we pass electric conductor, we pass electric current through an electric conductor. Okay, so we have to remember first thing is that, okay, that the if charges are moving, okay, if charge is moving, at that time field is generated around that charges, and that field is what, magnetic field. Okay, so now what happened here is also what happened, we place and one coil here in magnetic field. So now here in electromagnetic induction what happened, if you want to generate electricity, okay, we can generate electricity without using other electrical connection, or by without any supplying electric connection to it. Okay, so actually what happened in electromagnetic induction, that we have to see now. So electromagnetic induction is a phenomenon which tells us that we can generate electricity via using magnetic field. Okay, how that we have to see now. Okay, what in electromagnetic induction, that phenomenon tells us that we can generate electricity by using magnetic field, that is simply called as a electromagnetic induction. we can induce electricity in an electric conductor. Okay, we can induce electricity in an electric conductor by using magnetic field. It is simply called as a electromagnetic induction. Okay, so for that one example actually they given here. Okay, then here suppose this is, we take consider one coil. Okay, this is coil actually we have to consider. Okay, so that coil is connected to the battery. Okay, suppose this is coil AB which is connected to the battery. This is a positive and this is a negative terminal of battery. So as we turn on electric supply of this battery, at that time what electric current will pass through that coil. Okay, and we have to consider now another one coil here. Suppose this is one another coil that we have to consider over here, and only we have to connect here galvanometer. Okay, okay, galvanometer we have to consider here or connect here, because galvanometer tells us whether the electric current is passed through that electric circuit or not. It is very sensitive to electric current. Okay, how the working is galvanometer that we see in next topic, but simply you have to remember that we have to connect here galvanometer, and this galvanometer tells us whether if very small current is passing through this conductor, then that will also it denotes, because it is very sensitive to electric current in the range of milliampere current that will be measured, this galvanometer. Okay, so it is very sensitive to electric current, that also you have to remember. So here now we have to consider this coil AB which is connected to the battery, and electric current is passing through this coil AB. Okay, so now here we know as the electric current passes through an electric conductor, at that time what magnetic field is generated around that electric conductor. So we have to consider here magnetic field is present around this conductor due to the passing of electric current. Okay, if charges are in motion, at that time magnetic field is produced around that charges. That thing always you have to remember. So here, because of the passing of current through this coil, magnetic field is generated around this coil AB. Now what we have to do, simply we have to brought this another one coil, we call it CD. Okay, we have to brought this CD coil in the magnetic field of this first AB coil, because current is passing only through this coil and no battery connected, only coil is present here. Okay, CD is only coil, here battery is connected to the AB coil. So as electric current passes, magnetic field are generated around this coil AB, and if you brought this CD coil in contact or in magnetic field of this AB coil, at that time we see the deflection in magnetic field. If deflection in this galvanometer is takes place, at that time what happen, we have to understand that current is passing through this coil CD. Actually we not connect any battery to this CD coil, but still if only we brought this CD coil in magnetic field of this AB coil, at that time again what happen, it show deflection. It means that current is passing through this coil CD. Okay, now if you continuously brought in contact and place it stationary here. Okay, now suppose if here is all magnetic field is present. Okay, all magnetic field is present, we are brought in magnetic field. At that time when we are place this CD coil in motion, okay, means we are brought this CD coil in the magnetic field of this coil AB. At that time we see deflection, but when at one particular position, suppose we are constantly brought it this CD coil and placed it here. Okay, now this is CD coil is stationary. Okay, at that time current is not passed through this coil CD, means no deflection we see in galvanometer. Again we place back this coil CD. So as we start motion of this coil CD, at that time again we see deflection in galvanometer. Okay, only what is the important point here? Magnetic field is present over here. In that magnetic field we move this electric conductor. Okay, and we move electric conductor. At that time electricity is generated in that electric conductor when it is motion in magnetic field. But if that conductor is stationary in the magnetic field, at that time no current will pass through that electric conductor. So you have to note one point here. If we move an electric conductor in magnetic field, at that time electric current is induced in that electric current when that electric conductor is in motion. If it is stationary, then current not pass through this electric conductor. If it is in motion, then what happen? This electric current is passed through that electric conductor. So we can generate electricity by using magnetic field. Okay, so this point you have to note it, that if we move electric conductor in magnetic field, at that time electric current produced in that electric conductor. So now this is a one case. Now we have to see if we place this CD coil stationary, okay, and we move what? This AB coil. So if this is a stationary and we move it away from this coil CD, at that time also what happened? The electric current is introduced in coil CD. Okay, now CD is stationary, but we move AB coil. Okay, so as we move AB coil, the deflection we will see in this galvanometer. Okay, and suppose we stop motion of this coil AB here, then again it will not show any deflection. So actually here we move one coil both of any. Okay, at that time actually what happens, simply here magnetic field is present. As we go away from this conductor AB, strength of magnetic field of decreases. What? Decreases. So actually when we move from further here to here, at that time continuously what happens? Here magnetic field is very less, here somewhat stronger, here again stronger, here more and more stronger. Okay, so actually in throughout the motion continuously what happen? Magnetic field goes on changing. Okay, so actually what happen? Magnetic field goes on changing. Now here is also what happen? If you remain this CD coil stationary and if you move AB coil, at that time again what happen? Here magnetic field is much stronger, but as we go away from this CD coil, at that time if you move AB away from this coil, at that time again what happen? Magnetic field goes on decreasing. Here is much stronger. As we move this coil here, then magnetic strength here goes on decreasing. Again if you move here, again magnetic field goes on decreasing. From that Michael Faraday understood that if we can move an electric conductor in varying magnetic field, okay, if magnetic field is changing and we move that electric conductor in varying magnetic field, at that time we can generate electricity in that electric conductor. Or second, if you place electric conductor stationary and we change magnetic field surrounding to it, this second case, we have to move this coil now. At that time what happen? Again magnetic field around this stationary electric conductor goes on changing. Okay, so due to that, by using both cases we can introduce electricity, we can generate electricity in an electric conductor without supplying any electrical connection to it. Okay, so electromagnetic induction that phenomenon tells us that we can introduce electric current or we can generate electric current by using magnetic field. Okay, so here what happen, we can, here we not connect any battery, still we generate electric current in coil CD by using magnetic field of this coil AB by only changing the strength of magnetic field. Okay, and we can change the strength by both way, if you move this conductor or by moving this coil. Okay, by using both cases we can generate electricity around this coil CD. So electromagnetic induction phenomenon tells us that we can generate electricity in a conductor if we have to either change magnetic field which is present around the electric conductor. If a magnetic field is stationary, at that time electricity not generate, but if you move at that time we see deflection, means we here change magnetic field which is around this conductor CD. Okay, so today's lecture we have to remember that much part. Remaining part and some example of this electromagnetic induction we will see in tomorrow's lecture. Thank you.